Hey guys, what's up? Welcome to the little video I'm going to be doing on what happens when we have a mixed halogenation reaction. Um, most of the times when you see these reactions, the halogen will be the same. It'll be chlorine, chlorine, Br2 or I2. But there have been cases in the past where they asked if it was, let's say, chlorine and iodine, right? Chlorine, bromine. And so this was actually given on our exam too when I took this class, but they asked it as a curved arrow question. But the reasoning behind it is not too hard to understand. And so I'm going to, I'll try to give you guys an example of it. All right. And it's just gonna be a quick little video on it. So let's say we react it with ICl. All right. So how exactly does this work? Well, which atom is a double bond going to attack? All right. Remember, we're forming a three-membered ring intermediate here. So the double bond is going to attack one of the halogens, and then the halogen will in turn attack the carbon of the double bond. So which one is going to get attacked? Well, what we need to look here is we need to look at our electronegativity trend. Chlorine is higher up on the periodic table, so it's more electronegative than the iodine. So it's attracting electrons much more to itself, right? So there are more electrons, let's say, on the chlorine, right, than there are the iodine. And so what this means is the chlorine has a good amount of the electron density, and the iodine is getting some of its electrons pulled towards chlorine. So it's getting a little bit electron deficient, and therefore it's getting more electrophilic, right? Let's try to use our vocabulary terms. So here I'm going to make it a mixed alkene, or sorry, unsymmetrical. And so the double bond is going to attack the more electrophilic atom. That's how all these reactions work. We're going to attack the more electrophilic atom. So it's going to reach out and attack the iodine. This bond will break, and then the iodine will attack one of the carbons of the double bond. So now we'll get this structure here with our iodine and the three-membered ring and a plus charge, and now we have our Cl minus over here. Now remember how we discussed, oh wait, and I should not have drawn the double bond there. And so remember, how our three-membered intermediate works, right? A three-membered ring. The iodine is going to be leaning towards the carbon that is more electrophilic, or in other words, less substituted with carbon chains. So it's going to be leaning toward this carbon right here in purple, and it's going to leave this carbon over here in red more susceptible to attack by the chlorine. So the chlorine is now going to come in and attack that carbon, and that bond breaks. And so now our final answer is going to be the iodine over here, a methyl group here, and our chlorine on the more substituted carbon. So the shorthand way of doing this is knowing that the more electronegative of the two halogens that you have will attack the more substituted carbon, okay? And so that's just how you go through this question. This was given to us on something similar like this was given to us on our exam too, and a lot of people got it wrong. But the reasoning behind it is not too bad. And so if something here didn't make sense, please feel free to email me, go to the CLC and talk to the TAs. They're there to help you guys. And I will see you guys in the next video where we will talk about the last reaction on the last alkene addition pathway you need to know for this exam.